In this video, we want to talk about a case of repeated factors. And if you look on the denominator, you can see that the factor x minus 2 squared is repeated. So what I'm going to do is I'm going to decompose this fraction into 3 parts, one for each of the factors, but it's going to look a little different. So I'm going to have a over the first factor, the quantity x minus 1. But since the second factor is repeated, I'm going to put b over one of the second factors, and I'm going to put c over both. Okay, so that's a little something to note, right? This repeated factor, it gets written once and then gets written twice. And then I'm going to solve this problem the exact same way I've solved every other problem. I'm going to multiply everything by my fancy 1. So this is going to be a times the quantity x minus 2 squared plus b times the quantity x minus 1 times x minus 2 plus c times the quantity x minus 1, okay, over x minus 1 times x minus 2 squared. And that's going to be equal to 6x squared minus 19x plus 15 over x minus 1 times x minus 2 quantities squared. Okay, so I encourage you to pause the video and make sure that you can get this result. I'm basically multiplying every single fraction by its fancy 1. I'm adding the numerators together and putting everything over one denominator. Okay, at this point, I can set the numerators equal to each other. So I can say that 6x squared minus 19x plus 15 equals a times the quantity x minus 2 squared plus b times the quantity x minus 1 times x minus 2 plus c times the quantity x minus 1. And I have the same problem I had before. And that problem is, how do I solve for a, b, and c? So I'm going to need to let x equal something super, super easy. So what can I let x equal to make it easy to solve for one of the unknowns? Well, what if I let x equal 1? That might work really, really well. If I let x equal 1, that is going to have the effect of, basically, if I put 1 here, I'm going to cancel out b, and I'll also cancel out c, allowing me to solve for a. So let's let x equal 1. I'm going to just do some quick math here. So this is 6 minus 19 plus 15 equals a times 1 minus 2 quantities squared. And remember, when x is 1, 1 going in here and here makes all of that go to 0. So this is going to be, it's going to be 2 on the left, and then this is going to be equal to a, right? Because this is going to be negative 1 squared is positive 1, and if I add these together, I get 2. So I know a is 2. And I'm going to continue this process trying to find easy numbers for x. So the next thing I think I'll do is I will let x equal 2. Now, why would I want to let x equal 2? Well, I'm hoping that if x is 2, that'll cancel out b. Okay, and I already know a, so then I can solve for c. So let's try this. I have 6 times 2 squared minus 19 times 2 plus 15, okay? And that is going to equal, remember, 2 will be, a will be canceled temporarily, b will be canceled temporarily if I let x equal 2. So then I have c times 2 minus 1, okay? So make sure when you plug in x equals 2, even though a is 2, it still like temporarily cancels in this case. So that gives me what? That gives me, this is going to be 39 minus 38, so that's going to be 1 equals C. So double check my math, right? That's 24 minus 38 plus 15 is 39 minus 38, 1 equals C. Okay, and finally, I need to let x equal something super, super easy again, because I need to solve for b. So what's a good value for x? That's really, really easy. I'm gonna say that x is equal to 0. So I like 0 or 1 usually, because I think that's very simple. So if x is 0, plugging back into the original equation up here, you could see that I'm gonna get 15, and that's gonna equal, remember, a is 2, right? So that's gonna be a 2 there, so it's gonna be 2. But when x is 0, 0 minus 2 is negative 2 squared is 4, so it's gonna be 4, right? Plus, x is 0, so up here, that's going to be 2b, and x is 0, so here it's going to be negative 1, because c is equal to 1. Okay, so I'm basically plugging everything in that I know, and this is going to be 15 equals 8 minus 1 plus 2b. So 15 equals 7 plus 2b, and you can see that b is equal to 4. Right, if I subtract 7, I get 8. And so now I know that a, b, and c, I know what they're equal to, and I know that my fraction is going to be equal to 2 over the quantity x minus 1 plus 4 over the quantity x minus 2 plus 1 over the quantity x minus 2 squared. And that was equal to my original fraction of 6x squared minus 19x plus 15 all over x minus 1 times x minus 1 quantity squared. This is my decomposed fraction, and it's a much easier version than working with the original.